Let's dive into the world of JavaScript debugging. In this session, we'll learn how to master the art of debugging JavaScript applications using professional tools and effective techniques. The console object provides a range of methods for outputting information during debugging. Console.log is used for general-purpose logging. Console.info is used to convey informational messages. Console.warn is used to display warning messages. Console.error indicates error messages, and console.debug is used for debug-level messages. Here's how they look in code. We have a comment saying basic console methods example, and then each of the console methods, namely, console.log with a string user data, and some object user data passed as argument, console.info with string feature enabled, console.warn with string API deprecated, console.error with string connection failed, and console.debug with string debug info. Let's explore some advanced console methods. Console.group creates nested groups in the console output, which helps in organizing and clarifying complex log statements. Console.time and console.timeend are used to measure the execution time of code segments. Console.table displays tabular data in a formatted table, making it easier to read and analyze object data. The code here shows advanced console techniques with comment, and then console.group with the string argument user authentication, console.time with login duration as the argument, then console.table method with a JavaScript object as argument that has properties username, role and last login with string values, console.timeend with login duration passed, and finally console.group end. Below this, we have individual boxes that have the method title and description of the method like console.group, console.time, and console.table. Breakpoints are intentional points in your code where execution pauses, allowing you to inspect the current state of your application. They are useful when you need to investigate specific code paths, examine variable values, and understand the flow of execution. In this example, we have a function named calculateTotal which takes items as the argument. Inside the function, a breakpoint is set before the total variable declaration. Then, a for loop iterates through the items array to calculate the total. There are mainly three types of breakpoints. The first is a line breakpoint, which is the standard breakpoint that pauses execution at a specific line of code. Second is a conditional breakpoint, which pauses only when a specified condition is met. Third is a log point, which logs a message to the console without pausing the execution. In the code, we have a function named processOrder. A line breakpoint is added at the start of function, and a conditional breakpoint is set inside the if condition, and a log point is added inside the function before the return statement. Stepping through code helps in executing code line by line. Step into with keyboard shortcut F11, steps into a function call moving the debugger inside the function definition. Step over with keyboard shortcut F10, executes the current line and moves to the next line in the same scope. Step out with keyboard shortcut Shift plus F11, completes the current function and returns to the calling context. The code here shows the use of these methods. There is a function named calculateTotal which takes items as the argument and calls another function getItemPrice and getTax inside it. Watch expressions let you monitor the values of variables and expressions as your code executes. These expressions are automatically updated at each breakpoint. In the code, we have a function named updateCart, which takes items array as an argument and calculates the subtotal, discount, and total from it. And in the watch panel, we can see the values of the variables subtotal, discount, total, the number of items, and the number of items on sale. The call stack shows the execution flow of functions during runtime. The current scope displays variables and values that are currently accessible in the code execution. In the example code, there is a function named processOrder which calls another function calculateSubtotal, which in turn calls another function addItem. The call stack shows the functions in the order of their execution starting from the most recently called function. The current scope displays the values of the variables item, subtotal, tax, and total in the scope, where the execution is currently paused. Source maps are files that create a mapping between your original source code and the minified or transformed production code. They help in debugging the original code instead of the compiled code, maintain the readability of the code, and track the line numbers of the original source code. Source maps can be enabled in build tools like Webpack and Rollup. Here we can see the original source code of a class named Calculator, which has a constructor and add function, and on the right, we have the minified output of the same class. Below it, we have a simplified view of a source map file. Let's discuss some of the best practices for debugging in production environments. First, implement proper error tracking with stack traces and context information, which is crucial for understanding errors in production. Second, use a logging strategy with different log levels like debug, info, warn, and error, each having the right context. On the right side, we have the code implementation of a production error handler and a safe console wrapper. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.